Good afternoon. These are the notes for Chapter 2, Section 1, which is our first day doing that section, so 2.1a. These notes are about parallel lines. We're going to cover alternate interior angles, same side interior angles, corresponding angles, and alternate exterior angles. Okay, Roman number 1, exploring two parallel lines cut by a transversal. Okay, so let's start with some basic definitions. Parallel lines are lines that never intersect. Transversal. A transversal is a line that crosses two or more other lines. So if you look at this picture, these two lines are parallel to each other. They never cross. The little arrowheads mean that they are parallel. And then this one that cuts through them, this one is the transversal. The transversal is the one that touches two or more other lines. And then last, definition of straight angle is an angle that measures 180 degrees. Okay, so just looking at this picture, if you were to ask yourself, which angles look congruent in the picture? Well, you might say 2 is really small and 4 is really small, so they look congruent to each other. 1 is big and 3 is big. They look congruent to each other. Now, comparing these angles with this set of angles, if you look at 1 and 6, they look like they're almost the same. And 6 and 7 look like they're the same. The small angle 5 looks a lot like 2. And 8 and 5 look alike. Just by looking at these, you've actually come to the right conclusion, which is that the small angles, all 4 of them, are congruent to each other, and the big angles, all 4 of them, are congruent to each other. So we have some terminology to refer to the positions of these angles. We're going to label this drawing with that terminology. Again, you have two lines that are parallel, and just like we use tick marks for segments and angle congruency, for parallel lines, matching arrows mean they're parallel. So if they both have one arrow, they're parallel. If they both have 2 arrows, they're parallel to each other. Those are parallels. The transversal, I'm going to label T, is the one that touches both of the parallel lines. Okay, so this area in here, in between the 2 parallels, this area is called the interior part of the drawing. That's interior. The area above the parallels and below the parallels, those 2 areas are the exterior parts of the angle. So interior, exterior. If you have angles that are both on the right side of the transversal, like 4 and 6, we refer to these 2 as same side because they're both to the right of the transversal. Same side interior angles. Those are same side interior angles. 1 and 7, let's do those 2. 1 and 7 are referred to as same side because they're both to the left of the transversal, and they're in the exterior part, so they are same side exterior angles. Same side exterior angles. Now, another classification that we have, what if we have one angle that is to the left but inside, and one angle that is to the right and inside? Those 2 angles, because they're on different sides of the transversal, are called alternate, because they're on different sides, alternate interior angles. You can also have alternate exterior angles. I'm not going to label that on this drawing, but 2 and 7 would be alternate exterior angles because they are on different sides of the transversal, but in the exterior area. So these are some of the position words that you're going to need to know. And we're going to have some theorems that describe the relationships. All right, flip the page. The nice thing about the theorems in this section is that they all have titles, which means you don't have to write out the entire theorem. You can just write the title. Here's the first one. Alternate interior angles theorem. It says, if a transversal intersects two parallel lines. Okay, so here's our parallels. That's our transversal. Then, alternate interior angles are congruent. So looking at the picture, alternate interior angles. B and G are alternate interior angles. They're on opposite sides of the transversal, that's the alternate, and they're inside the parallels. So they are congruent to each other. The other pair of alternate interior angles that are congruent is F and C. They are congruent to each other. And again, remember interiors because they are inside the two parallel lines. That's your interior part. This is interior. All right, theorem, this is still 2-1. Same side interior angles postulate. It starts out, if a transversal intersects two parallel lines, okay, so here's our parallels, there's our transversal, then same side interior angles are supplementary. Which is a word we learned from Algebra 1. Supplementary means that they add up to 180 degrees. It does not mean they're the same as each other. It means they add up to 180. All right, so let's look at some pairs of lines. Let's start with same side interior. So B and C are same side interior. They are not the same as each other, but the measure of angle B plus the measure of angle C will equal 180 degrees. The other pair of same side interior angles are F and G. Again, they are not the same. You have a small one and a large one, but when you add the measure of angle F plus the measure of angle G, they add up to 180 degrees. They are supplementary. Okay, Theorem 2-2. Corresponding angles theorem. If a transversal intersects two parallel lines, okay, mark the parallels, that's the transversal, then corresponding angles are congruent. Okay, corresponding angles, there's actually 4 pairs of corresponding angles in a drawing. Corresponding refers to the fact that they are in the same position. They're in the same position in their group. So we have 2 groups here of angles. Corresponding means they're in the same relative position. So B and D are both top right, so they are congruent to each other. A and C are top left, so they are congruent to each other. E and G are bottom left, so they are congruent to each other. And then, I'm out of colors, then F and H, 1, 2, 3, 4, 1, 2, 3, 4. Those are congruent to each other. So same position in their group, then they will be congruent. All right, flip the page. Okay, Theorem 2-3, alternate exterior angles theorem starts out the same. If a transversal intersects two parallel lines, okay, so here's our parallels. This is our transversal. And this one is a bit of a typo on, so just scribble that part out. We say then alternate exterior angles are congruent. Alternate exterior angles. Okay, there's two pairs of these. Now first off, exterior means they're outside the parallel. So there's two exterior areas. Alternate means on opposite sides of the transversal. So we have to the right of the transversal, to the left of the transversal. Those two are congruent to each other. We have the left of the transversal and the right of the transversal. Those two are congruent. Alternate exterior angles are congruent. Okay, let's do an exercise. If the measure of angle 4 is 118 degrees, let's label that. What is the measure of each of the other angles? Okay, so if you remember, angles that are across from each other are congruent. The big angles match. So if 4 is 118, 2 is 118. Now, same side exterior angles are congruent. So 4 and 8 are same side. I'm sorry, corresponding. Corresponding angles are congruent. So 4 and 8, they're both in the bottom left. So they are congruent to each other, which means 8 is 118 and 6 is 118. Now, to figure out what goes in the other position, remember that same side interior angles are supplementary. So those two angles should add up to 180. So 118 degrees plus angle 5 has to equal 180, and we can solve for that. Subtract 118, you get angle 5 equals 62 degrees. So number 5 is 62 degrees, which means 7 is 62 degrees, 3 is 62 degrees, and 1 is 62 degrees. Again, the very first exercise we did, you visually figured out which 4 were the same and which 4 were different. That hasn't changed. There's just theorems to prove the fact. All right, let's go to example 2. Solve for x. Okay, so we need to figure out a relationship between the 5x plus 35 and the 45. Right now, there isn't one. Here's our two parallel lines marked by a transversal. So here's a theorem that we will come across, and that is that if you have angles that are across from each other at an intersect, those are called vertical angles. And there's a theorem that says vertical angles are congruent. So if they're across from each other, they are the same. This is one we haven't gotten to yet, but we're going to use it. So 45 is across from angle 6, so angle 6 must also be 45 degrees. Okay, now looking at 5x plus 35 and the 45, we have to determine the relationship. Well, both of them are to the right of the transversal, so they are the same side of the transversal. And they are in between the parallels, so they are same side interior angles. We have a theorem that says same side interior angles are supplementary, which means they add up to 180. That's what's going to get our equation. Same side interior angles are supplementary. So 5x plus 35 plus the 45 has to equal 180 degrees. And then we solve for x. So 40, 50, 60, 70, 80. So 5x plus 80 equals 180. Subtract 80. 5x equals 100. So x must be 20 degrees. So you're going to use these relationships to help your